My name's Ariel Rainey, and I'm a graduate student at the Colorado School of Mines. I'm presenting a series of videos that will demonstrate a new concept in engineering education about funds of knowledge. Funds of knowledge, defined as a collection of knowledge that is based in families' intercultural practices that are a part of their daily routines, work experience, and culture, and also defined as skills and knowledge that working class families can possess to survive and make a living, are a new concept in engineering education that emphasize how engineering students who don't fit the typical demographic can use these skills to progress in their engineering education. In a study that surveyed a diverse pool of engineering students, funds of knowledge such as tinkering and perspective taking proved to not only further students' interest in engineering and their beliefs about their competency to perform well, but it also furthered their decision to continue. Funds of knowledge draw attention to a wider array of activities that students who come from low-income, minoritized, or first-generation backgrounds can utilize on their journey to be successful engineers. In the following videos, we'll see how funds of knowledge can be utilized in a classroom environment to support students' learning and being able to solve different engineering problems. Meet Leo, a student who worked at a warehouse prior to coming to college. During his experiences, he developed a fund of knowledge called tinkering knowledge, which represents an understanding of tools and building things. He learned a lot about forces as it pertains to different belts, pulleys, and other mechanical structures. In physics-heavy engineering courses, such as statics and mechanics of materials, warehouse experience and other forms of tinkering knowledge can be useful for understanding engineering processes.
So you ready to work on the statics homework?
Yeah, I am. Let's pull it out.
Alright. So, did you figure out all the forces yet?
I think so. You want to compare our free body diagrams?
Sure. So, here's what I have so far. At point A, I figured there's a force acting in the x direction, and at point B, I figured there is a upwards vertical force acting in the y. And the hinge at point C had me confused at first, but I'm pretty sure there's forces acting in all three directions.
I would argue that for point A, there's a vertical force acting in the y direction, and the horizontal force would be in the z direction, not the x direction.
But, I mean, if you look at the drawing, it definitely looks like the pin is acting in the x direction.
Yes, that could be deceiving, but let me tell you about my experience in the factory. So I worked with a lot of different bearing systems, and with some of those bearings, they kind of acted like thrustless bearings, which is what is talked about in this problem. For thrust bearings, there's forces acting in the x, y, and z direction. For thrustless bearings, however, when I was working, I saw that you could slide in the x direction, meaning there's no force in it.
Right. So what you're telling me is that there's no force in the x direction, even though the platform isn't moving at point A?
Right, and that is because there is a restrictive force from the hinge in the x direction. So there's a force in the point C, which prevents it from moving in the x.
So then, doesn't the point of the pin seem a little unnecessary?
Yeah, it's kind of redundant. It's just an additional support to prevent the platform from slipping or sliding. If there was a force pushing against, if the pin did push against the platform, you could argue it's a pointless force.
Meet Cassie, who grew up where everyone worked multiple jobs and juggled one source of transportation. This caused her to understand the fund of knowledge called resourcefulness, which helped her navigate multiple demanding priorities among limited means. ABET criteria emphasizes the importance of designing with specific needs that considers a multitude of different factors, from social to political to economic, and being able to design and prioritize various needs of a project considering those factors.
So, for the water distribution system, I've been researching some of these least cost-effective methods for filtering and distribution. Thinking something like this filter cup, maybe a cheesecloth, seeing some cheap options for mini UV lights as well.
Yeah, and we're thinking of purchasing life straws for the community too.
I think we gotta go more basic to try to think about what's already readily available.
It's a pretty rural community.
And we're allowed to transport materials and hire help.
But I think we want something that uses materials already available that's easy to assemble. And so we don't need to spend a ton of money and time on budgeting for some expert salary. I think we use what we have and we make something work.
So what type of materials are you thinking?
We need to make sure the water will meet a certain standard in the end.
So when I was researching the typical contaminants in the water, it was seeing a lot of different suspended soils, bacteria and such, and so I think we can use the natural landscape in our filter system, looking at like the plants, soils, rocks, clay, that type of thing. And after the water is filtered through our media, it sits in a glass jar that gets boiled, and that gets it to be disinfected.
I just think we may be simplifying our solution a little too much.
I think we need to start from the basics. And as necessary, add more money, resources, human capital. I don't think it's the best approach to a project to assume that we're going to have access to certain things that actually require more money and time and planning than we thought about.
I see.
And we can still test our water here and make sure that we meet the necessary standards, and maybe network around, see if we can get an actual sample from the community.
Yeah, that is a good idea.
I just want to make sure we give the community the best design we can.
And to offer a different perspective, when I was growing up, we just didn't have access to money, transportation. My parents weren't even around half the time. So it really forced me to think outside the box and on my toes.
Well, we definitely need that sort of thinking now. Classroom activities could provide opportunities for students to utilize the funds of knowledge they personally identify with towards their engineering education. This could look like students taking apart and rebuilding common household items, designing for affordability, and learning from skilled tradespeople. Research also shows that first-generation college students possess unique knowledge concerning interpersonal relationships, such as perspective taking and mediational skills, and this is essential to collaboration, teamwork, and successful engineering projects. Incorporating funds of knowledge can better equip students to design for diverse pools of stakeholders. This is only the engineering future that we can aim for. My name is Ariel Rainey, and thank you for allowing me to express the importance of funds of knowledge to engineering education.